So we have a nice little system here that's giving us the closest points for each particular particle, but we're still going to need to do a subtraction so that each point knows the knows the direction to go for each one of these points here. So for that, we're just going to do vector subtraction. Okay, so we'll get this position, and then we'll subtract it from our current point position. Wha-bam. Okay, so we got that, and we'll take this and plug it into here. So we'll visualize this vector. Let's look at them as vectors. There we go. Okay, so this is what we have now. And we're going to use this within our dot product. So we'll get our dot product. Put you in there. And the second vector we're going to use, remember from before, it's going to be our geometry normals, because this is what we want to know if we're facing. And we're going to use this within our if. If, and then our less than. Plug those in. First value. Let's reorganize that. So we're going to see if this value, let's hide these vectors, and then let's show these. Let's see which is, if they're positive or negative. So if it's outside, let's make sure this is numeric. It is. Now let's make sure that we don't have this on, which we don't. Oh, there we go. In this case, you see here the if isn't connected to anything, so we need to make sure that that if we want this data stream to be visualized, we need it connected. But in that case, we really don't care. We'll just show this. So, and then we'll make sure that this is set to numeric. We'll hit play. So these values are negative, and then the second they jump in, inside the values, they're positive. And if we wanted to swap that, we just need to swap the subtract. But it doesn't necessarily matter, since now we know that outside means negative. So the if statement, there we go. So the if statement that we need to check to see if it's less than 0, which it is. And I changed the epsilon. This is just a precision value. Just put it to 0. Okay, so we're checking to see if it's negative, and if it is negative, then we want to modify our velocities. So we're going to need our point velocity, and as we looked at before, we're just going to get point or particle. We're going to get particle velocity here, and in the end we're going to be setting particle velocity. Let's get rid of this set data node right here, and this deals with our velocity steering that we did before. So with this, we'll with the particle velocity that we got here, we want to make sure that the magnitudes are the same. We don't want to change our magnitudes, and we'll get that set up here. So we'll go ahead and do resize vector, and we're going to take our old velocity here. So this is the same setup that we did before, and actually what we're going to do, we're going to plug this into here, because this is what we're going to be getting. We're going to be working with these velocities that way, and we'll plug this into our new port. I'm not even sure why I made so many ports, but that's okay. So if the condition's true, if it is negative, actually I want this. If it is negative, then we want these values to take effect. So in this case, what we have, If it is true, they're going to continue to go up, and if it's false, everything should stop. So let's go ahead and find this null here. So the particles go, and the second they enter here, the value is now true, and their velocities change, or excuse me, the values becomes false, and the velocities change to here. So if I go ahead and make this 2, you can see they now start inheriting this value. So I actually have control of them while they're in here. Woo, SuperControl. So what we're going to want, we kind of want the opposite behavior. On the outside, if it is true, we don't want them to maintain, and if it is false, we want them to maintain. So that's something that we're going to want, and we're actually going to use this version of that. And if it's outside, what we're actually going to want, we're going to want to move to that position, so it's moving towards the geometry. So we're definitely need an add, because if we remember before, vector addition allows us to move our particles. So we're going to get our current velocity, and we're going to add, and what we can do, we can grab the normal itself. So we'll grab the normal, we'll add the normal, but the opposite direction, so we can negate that. Okay, and we're going to take that and we're going to plug it into our true value. So we have a true and false. So what we're doing, we're getting our particle velocity, and we're adding it to the reverse of the normal, which is going to tell the particles, hey, come this way, I want you to come closer to me, I got candy. And you know what, this resize stuff, I'm just going to put it out here. Let's get this out. We'll take that out. We'll just put in our velocity, our normal velocity here. And then we'll just resize everything at the end. And then we'll grab an add here. Might be a little confusing, and sorry for that. Add current velocity. You know what? I kind of checked this out. Let me just delete this a little bit. So we have this negate, and we have our current particle velocity. This should be everything, and we just need that resize in here. So we'll grab this, and you know what? We'll just take this new vector, plug it into here, and then we'll just take this to speed, and that should be all we need. There we go. So let's go ahead and just check out what we have. So if we move this, the particles now move. Let's turn off this visualization, hide values. The particles now move to be included inside of the fun in here, and the second that condition, the second they leave the geometry, they want to move back. So this is all that we did right here, and we can change the vectors that we're using in order to get back in, but the best thing to do is experiment with that. But now we have a system where the particles, they want to stay within the system here, and they're doing their thing. So very useful setup. And once you've grasped kind of the basics here and how all of this is working, you actually have a lot of control over your system. So this is just some mental stretching is needed in order to get this as part of your tool set. But once you get it, it's happy vectoring.